Hello everyone, I'm Rahi from Rahi44 and welcome back to the channel. So what if I told you that by the end of this video, you could teach your computer to recognize objects and detect them also, like cars, people, cat, bottles, anything, just by training it on your own dataset. Sounds cool, right? Well, today we are diving deep into the world of object detection with YOLO. And not just a theory, we are also going from scratch to full-blown predictions. So grab a snack, open your IDE, and let's build some amazing AI magic together. So first of all, what is object detection? Before we jump into the code, let's clear about the basics. Object detection isn't just about finding what is in an image. It's about locating where those objects are. For example, if I see in Google, you can see there are some bounding boxes with the classes. So, for example, this is a person and this is a cat. This is also a person. You can see even this is a broader picture. For example, like when you're driving a self-driving car, it actually see all the objects around you. So when it comes to real-time object detection, YOLO, which means you only look once, is just a superhero, fast, accurate, and crazy powerful. So when it comes to real-time object detection, YOLO, which stands for you only look once, is just the superhero. It's fast, accurate, and crazy powerful. So let's talk about the tools we needed to set up our device. So first of all, YOLO supports PyTorch. So for that, we need to use PyTorch. So for that, let's type so inside this, you can see stable, Windows, P, Python, and CUDA. It depends on your driver version actually. If you don't have any GPU, you can use CPU, or if you have AMD GPUs, so you can use ROCm. By the way, I'm in Windows, so I'll be using this, but if you are on Mac or Linux, you can see this. And for macOS, you can select the default one. It will use PyTorch with MPS because it's quite tricky, Apple has not NVIDIA GPUs. So you just need to copy this command and paste it inside the terminal. Since I have already installed this, so I don't need to install it anymore. And also, usually training stuffs are happening inside the Jupyter notebook. So I suggest you to install Jupyter notebook in your VS Code. And by the way, you must need a dataset to work on because you will train the dataset for YOLO, So let's prepare the dataset. For training the dataset, we'll be using Roboflow. It's the best among any data annotation platform. So if I go into this, you can see it's blazingly good and it has some amazing features. So let's sign in. So I have some data sets you can see. So move to some another plans. Equate cortex. Okay. There is a great feature in Roboflow, which is the Roboflow universe, where you can download many datasets from the global platform. So let's go to the Roboflow universe. So this is the Roboflow universe where you can see there are too many datasets here. Even you can search them, filter them. For now, I'll be using this forklift dataset. Here you can see it's downloaded for 900 times and 20K views. That's huge. And you can even fork this project in your own profile so that you can later use for many purposes. And the tags are object detection. And this dataset has two classes, which is forklift and the person. So these are labeled here. Okay. Even you can build your own dataset from scratch, but since I don't have any custom datasets, I'll be using this one. So let's fork this project. I'll be using this one. It's copying the dataset. Well, it's successfully forked it. So here's the total dashboard. You can see there are 295 images for training, 84 for validation, and 42 for testing. And if you have more images, you can just upload it here. And the dataset has these images, and the classes are forklift, person. So let's see if we have any null dataset. Okay. It's unlabeled. So let's label them. So as you can see, there are two main ways to label them. One is this bounding box and another is polygon. When you will be using segmentation, then you will use the polygon. And for basic stuffs, bounding, this one is enough for you. So let's label them. This is the forklift. So let's select forklift, and this is the person. So let's use person here. Well, we have completed labeling. Now let's go back. An annotation. It's already annotated, so I don't need to annotate it. Even you can add multiple persons to label them, or even you can just hire people here from Roboflow. Okay, the dataset part has been done, and let's go to the versioning. Here you can select the parameters for versioning. Images are okay, so let's edit this one. There are some defaults here, and which is the standard one, but you can rebalance them just sliding like this. So let's cancel them since it's already been created. So continue. And pre-processing. Pre-processing is a very important part for creating a great dataset. I don't think we will need to use this one, but grayscale would be great. Just look at this. The images has been converted into grayscale. So let's apply them. And I don't think we don't need to use them. So let's continue. And now the augmentation step. Here you can see there were many features like nicely dotted, crop, saturation, hue, blur, even noise. So I'll be using the noise one since the images can have many noises, but if you use too many noise, it will give warning because it will degrade the dataset's quality. So let's use a small variant of that. So apply and some blur effect. Oh, I think this is good. So let's apply them and continue. Okay, you can select these options. I'll need more images, so I'll be selecting this one and create. So it will take some time to create the dataset. Okay, it's done. So this is the final dataset versioning. So this is the final version of the dataset where you can see training set has a lot of images, which I got from augmentation. And let's download it. So you can just download it as a zip to your computer, or you can just show download code, which is very helpful for Jupyter notebooks. And here you can see there are many versions for dataset exporting. For TensorFlow, you can use this one, and for YOLO, you can use this one. But even there are also training methods, for example, using Pascalvox, like OpenAI. For Transformer, you can use Florence or Polygamma. And the most famous dataset format is Cocoa. But we'll be using YOLO here. So let's select YOLOv11. So let's continue. It will take some time. Wow. Okay, let's go to the YOLO part. So this is the documentation page for YOLO11, and YOLO11 is really good at real-time object detection and image segmentation model too. So there are many great step-by-step learning procedure here. And this is the total history of YOLO. So as you can see, this is released in 2015, and it's really got high popularity. So this is the latest one, YOLO11. So we'll be using this thing. And for detection purposes, here you can see this is detecting very well. And for every YOLO model has some segmentations like nano, small, medium, large, and extra large. And there are some parameters here. So this is how you can load the YOLO models and train them. So let's make things easy and just go to the training notebook. So this is the training notebook here, and I'll give the link of this notebook in the description. So before that, we need to check if our torch is compatible with our CUDA driver. So for that, we need to run this code. So let's run it. Yeah, great. You can see I have one GPU and CUDA available is true. So let's go to the training phase. So this is the whole notebook, and this NVIDIA SMI command is used to check the NVIDIA driver. So you can see it's working properly. So this is the home directory of my code folder. You can see the YOLO tutorial. This is the alternatives library and supervision with Roboflow, because so I'll need these libraries. It's checking my alternatives as I have already installed that. Yeah, you can see the setup is complete. All the informations are quite accurate. So you'll have both CLI and Python version. First of all, we will see the CLI. Here you can see this is the image of a dog, and it will predict using an YOLO11 nano model. It's done, and it took 51 milliseconds. You can see this has 2 persons, 1 car, 1 dog, and 1 handbag. So let's see the image. It's good. The results are this, and the output result has these parameters, which are the confidence, the class probability, etc., etc. So if you want to put the boxes, then we need to use this codes. So that's it. So let's come to the final part of this video, which is how to train or fine-tune a YOLO11 model on a custom dataset. So let's create a folder named Dataset. By the way, you can see that a runs folder is created for the dog, and the training process will also happen in the run folder. Okay, if some of you are familiar with Linux, then you know this command of cd, which is for current directory. And Here comes this gibberish word, which are the folder we got from Roboflow. You can see this is the API key for the Roboflow, even though it's not very useful if someone really copy this, because it's just for the same folder of Roboflow dataset. This is my workspace and this is our project. And we downloaded it using YOLOv11. So let's run this. It will download the folder in the dataset directory and then unzip it. Yeah, it's downloaded the folder. So you can see the test, training, and validation. So if you go into the images, then you can see this image of forklift. And there's also some humans. Okay. Now let's go to the training part. If we see the dataset location, this is it. And now let's come to the final coding, which is the fine-tuning process or the training process. So we will be using a small model of YOLO11 and it will fine-tune based on this model. And this is the data.yml file, which is this. It has the following parameters of the dataset, which are the training, validation, and testing. And these are the folders of it. This is the classes. And this is some Roboflow sheets. And we'll be using it for 15 epochs and image size will be 640. And the device is CUDA because I have NVIDIA GPU installed on my PC. So let's run it. It's downloading the small model of YOLO11. So you can see the parameters of the YOLO model with layers on it. The total parameter of this model is 9.4 million, which is quite good. And if you use the YOLO medium model, it has around 21 million parameters, which is good. And if you want to use larger models like the large or XL, then those have more parameters like 40 or 60 million. So the training process has started with epoch 1. You can see the GPU memory, which is 4.3 gigabyte, and the losses like box loss, class loss, etc. After each epoch, you will see the losses will get reduced, which is what we wanted. You can see the class losses has reduced to 1.4, and this loss will also degrade. Let's just wait for a few minutes. The main loss here is the class loss. You can see it reduced from 1.488 to 1.48. And now it will go around 1.36 or something like that. Yeah, 1.37. It has a constant memory of 4.4 gigabyte. If you want to see the task manager, so the GPU is using its 92% power with some memory, and my RAM is using 28 gigabyte of it. Here you can see each epoch takes around 16 seconds, but if you use larger models like in medium or large or XL, it will take more time based on your GPU. So the losses are really reduced. We do have only 4 epochs left. Yeah, the training phase is done and the models are saved at this part, which is runs, train, weights, and measured PT. So if you want to inference the model, you have to use this path. So these are the matrices. Okay, so let's see the confusion matrix. It's quite good, but actually not 100% great because it missed some classes. It happened because I used a smaller model. If you want to use larger models, the confusion matrix will be much more accurate. This is the result. curve, you can see the losses are getting down and the precisions metrics are getting up. This is what we wanted. So let's see the validation batch, which are this, and it's perfectly done. So let's fine tune the model on the validation dataset. Here you can see the path of the model, which is base.pt, and the dataset location. And this is the mode, validation mode. Yeah, it's done. And let's inference it with the validation part. The images are saved true, so it will save the image at this part. Total 42 images. So let's see the first 10 images with this. So it perfectly detected the forklift, but it missed some persons because it's a smaller model. It can make mistakes. It's good. It's good, but it did 2 boxes on a single person, which we didn't want. Same goes for this. It's perfectly done. Same goes for this. It detected 2 forklift, but we have only 1 here. Yeah, it's good. It's good. It only detected the forklift, but didn't detect the human. So that's it. This is the overall process of how you can train YOLO model from creating dataset to final PyTorch code. And we can see the models didn't do quite well, but not so bad also. So that's it for today's video. If you like this video, give it a thumbs up. And if you have any questions, then please feel free to write them in the comment box and I'll try to answer that questions. So goodbye, adios, sayonara.